You've probably heard that space is silent, that a black hole, of all things, makes no sound at all. And that is almost true. Almost. Because in 2003, astronomers aimed a telescope at a distant swarm of galaxies and found a sound hiding there. One single note, held without stopping for 2.5 billion years. It comes from a black hole. And once you see how something dead and silent can sing, and why you could never hear it, space stops feeling quite so empty. The story begins in the Perseus cluster. It is a crowd of thousands of galaxies held together by gravity about 250 million light years from here. That number is impossible to feel, so try this. If our whole galaxy shrank to a single grain of sand, Perseus would sit across the room. This is a big, quiet place. And at its very center sits one giant galaxy with a supermassive black hole inside it, weighing millions of times more than our sun. In 2003, a team led by the astronomer Andrew Fabian pointed NASA's Chandra X-ray telescope right at this cluster, not for a quick glance, for nearly 1 million seconds. That is almost 2 weeks of light, gathered drop by drop. And in that deep, patient image, something appeared that nobody was looking for. Rings. Faint, evenly spaced ripples spreading through the gas around the black hole, exactly like the rings that open when a stone drops into a still pond. It was so strange that, at first, a few people wondered if it was just an error in the data. It wasn't. This pond was the size of a galaxy cluster, and those ripples were sound. Now hold on. Sound in space? We usually get this backwards. Sound is really just a pressure wave, a push that travels through stuff, air, water, anything. Out in the wide gaps between the stars, there is almost nothing to push, so there is almost no sound. That part is true. But a galaxy cluster is not empty. It is filled with a thin gas, heated to millions of degrees, far hotter than the surface of the sun, and stretched between the galaxies. Astronomers call it the intracluster medium. You can picture it simply, a vast, faint ocean of glowing plasma. And this is the part I love. This gas is so thin it is almost a vacuum, emptier than almost anything you could picture. And yet, stretched across millions of light years, it is more than enough to carry a wave. So where does the wave begin? With the black hole itself. As it feeds, it fires huge jets of energy outward, blowing enormous bubbles in the gas, some tens of thousands of light years across, each one wide enough to swallow a small galaxy. Every time a bubble swells, it shoves the surrounding gas. That shove rolls outward as a pressure wave, a sound wave. In a very real sense, the black hole is beating a drum the size of a galaxy. And a drum that big plays a very, very low note. When the team measured how far apart the ripples were, they could work out the pitch. It came out as a B flat, but not a B flat anyone will ever play. This one sits about 57 octaves below the middle of a piano, and every single octave means cutting the pitch in half, again and again. Let me put that in perspective. A whole piano covers about 7 octaves. To reach this single note, you would need a keyboard stretching more than 30 feet, longer than a city bus. And the wave rises and falls just once every 10 million years. 10 million. The last time this note finished a single beat, our ancestors had not yet learned to stand upright. That is why you will never hear it. Your ears catch sounds that shiver between 20 and 20,000 times a second. This one takes 10 million years to shiver once. It is not too quiet for us. It is too slow. This is a note kept on a cosmic clock, holding steady since long before complex life emerged on Earth, which leaves one strange question. If nobody can hear it, how do we know what it sounds like? In 2022, NASA decided to let us listen. Not by inventing a sound, but by taking the real ripples in that gas and speeding them up. And now, the honest part, because it really matters. They lifted the note up by around 57 to 58 octaves, making it quadrillions of times higher, until it finally landed in the range your ears can catch. So what you are about to hear is not a recording. It is a translation. The rhythm and the pattern are real, pulled straight from the data. Only the pitch has been raised so that a human being can finally sit with it. Listen. That is the sound of matter falling into a black hole, carried across 250 million light years and sustained for 2.5 billion years, folded down into something you can hold in a single breath. And that raises a quiet question that some scientists genuinely enjoy arguing about. If we have to lift it this far just to hear it, is it really sound at all? Or only a pattern we have chosen to listen to? Perhaps it is a little of both. But it does something far stranger than simply sound beautiful. This note actually shapes the whole cluster around it. Those sound waves carry energy. As they roll outward, they gently warm the gas. And that steady warmth does something quietly essential. It keeps the gas from cooling, sinking, and collapsing inward. Without it, all that gas would cool, rain down toward the center, and burst into a runaway storm of new stars. Instead, the black hole's song holds the whole cluster in balance. Astronomers call it a kind of cosmic thermostat. Think about that for a moment. The reason this entire cluster hasn't drowned itself in new stars is a note. A single, patient vibration holding the gas in balance for billions of years. And the story is not finished because we do not fully agree on how it works. The ripples are real. Everyone agrees on that. But exactly how they heat the gas is still debated. Some researchers think the heat spreads through the wave itself, carried by electrons racing ahead of it. Others argue that a hidden sea of high-energy particles, cosmic rays, soaks up the energy instead. Both sides are looking at the same singing cluster and reading the music differently. And that is not a flaw in the science. It is the living edge of it. The exact place where we are still listening. Some go further still. And here we step from solid evidence into pure speculation. So hold this one loosely. The energy behind this note is hard to picture. It sings across 30,000 light years, a third of the way across our galaxy. And that has led a few thinkers to a strange idea. Maybe sound and structure are tied together at the deepest level of the cosmos. Some even ask whether our whole universe might sit inside a black hole. There is no proof for that. It is a thought, not a theory. But it is the kind of thought a singing black hole invites. So, space is silent. That is what we are taught. But drift close to a cluster of galaxies, into that thin ocean of glowing gas, and you would find it trembling with a note too deep and too slow for any ear, a note that has been playing quietly since long before complex life appeared on Earth. So the next clear night, when you look up at that quiet dark, remember this. It was never really quiet. We just had not learned how to listen yet. If you want to keep listening, there is a whole universe of these sounds, like Voyager's plasma waves, or the echo of a dying star, and I have gathered them in the playlist on screen. Stay curious, and I will see you out among the stars.